Hi everyone, welcome to the third video of Module 8. Now that we have already added the dataset to the Google Colab notebook, now it's the time to explore it. So because we are having this CSV file, the first thing is to read the CSV data and then start exploring it with the help of Pandas library. And then we're also going to make some kind of conclusions and observations about the dataset. So let's get started. Now the next step would be to read the CSV data that we are having in a Google Drive. So for that, I'll first require the path of that CSV file. And for that, I'll go to the drive. And I know exactly where I had stored this data into my Google Drive. That is inside my Drive folder. So I'll go to that My Drive and simply search for that one file called as SDSS tabular data. So just keep on scrolling down until I find that data. So keep on scrolling down. And I guess it's somewhere over here. Well, I'm not able to find it. So SDSS tabular. Oh yeah, there it is. So I'll now copy the path of this. Close this up. And over here, actually over here itself, I'll be using the pandas library in order to read the CSV file. And here is where I'll be pasting this path as a string. And if I run this code, it should read the CSV file. And now if I have to display the first 5 rows from the data, I just type over here df.head and write 5. By default, it takes 5 over here as an input and run this code. Here are the first 5 rows of the data that is printed right in front of us. So that's the output that we are having. And to understand that what does each and every column mean over here, I have written a quick description of it, a one-liner description of it. For example, this object ID is the unique identifier for an object in the SDSS imaging. Then array and deq are useful for the coordinates that we want to find out of the object that we are looking at. So each and every object will have its unique right ascension and the declination coordinates. Then UGRIZ, here are the magnitude of the flux of that particular object that we are looking into in different kind of wavelengths, starting from ultraviolet, going all the way up to infrared and near infrared. Then after that, this runs, rerun, chem call, field, spec object, all these kind of things are with respect to the parameters that we have for the SDSS imaging. Then we are having the redshift value as well, which is the measure of the change in the wavelength of light emitted by an object due to its motion related to the observer. And then we are having plate and then the MJD, that is the modified Julian date of the observation. And finally the fiber ID. So if you are very much new to this kind of terminologies, I'll really recommend that you come up over here, click on this link as well as on this link. In both of this link, what you will see is a way through which you can understand that how we have got this kind of parameters. So if you go into the glossary over here, you will be able to find all these terminologies. Let's say, for example, if you are very much new to this run or rerun, I can press Ctrl F and search for, let's say over here, rerun. And then keep on pressing enter. Over here, I can see that there is something called as rerun. If I click on this, it will redirect me to this particular definition of the rerun. And you will try to understand what it means. So like this, you can go ahead and go through all these kind of terminologies that we are having over here. But the only one thing you need to know is that there are some different kind of outputs that we obtain from the SDSS imaging. That is on the basis of all the photometric information, the telescope information, everything, we are going to use it in order to classify if a particular object that we're looking into is either a star, galaxy or quasar. So that's the whole idea. Apart from this glossary, you can also use this particular reference, which is about understanding the SDSS imaging data. Over here also, everything will be mentioned about the chem calls, run, fills, and a lot more things. There are all the 5 filters, R, I, G, U, Z, right? All of this will be explained over here. So this reference is also very much useful if you are very much new to how the SDSS imaging data actually works. I'll just close this up. And after this, what we are having is to explore the data further. I'll just find out what are the unique elements present in the class column. And for that, what I can do is I can simply say that in the data frame, we have a class column, which I'm referencing with the help of a square bracket. And then to get the unique values, I need to use value count functions over here. So I will use dot value counts. I don't need to pass anything into the bracket. So what this actually is going to do is if I just copy this code and paste it in the new code cell over here and run this, you can see that we got 3 different outputs saying galaxy, star, and quasar with the respective counts. So because we are having a length of 3, this unique is going to have 3 different unique values, and therefore I'm going to say that what is the length of this unique. So it's going to be 3. So there are 3 unique classes in our data, and then I'm just going to print all of this output that we have got over here. So now if I run this code, this is the output that we are able to fetch. It's pretty much very similar to what we have got over here, but yeah, we're just customizing it with the help of the print statement. So I'll delete this code cell, and this is much more better way of looking into the data. And it says that there are 3 unique classes in our data, and then therefore the classes that we are having is galaxy, star, and quasar with respective numbers that is present in the data set. So it means galaxy is present as 4998, stars are 4152, and the quasars are 850. So that's the kind of data that we have looked into. Now, apart from this, I'm also going to visualize the different kind of things that are present in this data, but that will be the part of the next video. But for now, if I have to get the unique values for the rerun and the object ID, and if I run this code cell, I'm just decorating all of this so that it looks neat in the output. I am saying that I want this kind of dashes for 60 times. Then I'm going to print one statement between that. And after that, again, I want this dash for 60 times. And I'm saying that rerun column has 301 values repeated for 10,000 times. And then here is the proof for that. I'm saying that I'm printing the rerun, and I'm saying what are the unique values. There is 301 is the only one unique value that is repeated for 10,000 times. And if I show you what is the size of the data, or if I show you what is the shape of the data frame, so for that I'll need to type df.shape. So you can see that there are 10,000 columns, 10,000 rows and 18 columns. So for each and every row, we have only one constant value. So we can ignore this over here. And similarly for the object ID itself, you can see that there is only one unique value. It is repeated for 10,000 times. So we can simply go ahead and remove this kind of columns from our data. But now we need to be really very sure and always have an opinion from the subject expert if we should do this. Now you might ask that why did I just choose rerun and object ID? Well, I've gone through each and every of the column and looked into the unique counts, especially if I think that there are constant values that have been repeated. So for that, I have done this particular step, and in the 2 columns, I saw that there is only one unique value that is repeated for 10,000 times. And therefore, I am deciding that I can go ahead and remove these columns when I'm going to build my data set for the training and the testing part. But yes, it is always a matter of fact that you always take this opinion from the subject experts, that if it is going to be helpful for us, or if it's going to be harmful for us if we remove this kind of columns, or if this kind of columns are really important for the data and we cannot remove it. All right, so you need to have this kind of opinion. But over here right now we are just removing this both of the columns over here. Now after this, the key point is that note that we shall remove these features later while preparing the dataset, as I mentioned, and then you can also keep it. But what's the use of showing the model the data that is just the constant? It's always going to get the same kind of data. But now, as I told you, that this is the subset of the large data, so it can have a different value of rerun, it can have a different object ID. The reason it can have the same object ID is over here because we're just scanning a specific part of the sky and we're getting the data from that part itself. And therefore, because it's a subset of the whole data, it is having a constant object ID over here. So that's why it is always an important thing to have a conversation with the subject expert before you remove any kind of columns. So over here, I just insist you all that you can always go ahead and keep this kind of columns, don't remove it, and just see if it's really affecting the outputs or not. Okay, all these kind of things, you can do it and try it by yourself. But in our case, I'm simply removing both of these columns because of the same reason that I don't want to show my model the constant data that it is having. All right. And then if I just scroll down and check the basic information over here, I can use df.info. It's going to give me all of the basic summary of the information. And we have already seen that there are 10,000 rows of data with 18 columns. And here is the information about the non-null count. All of these columns are having no non-null counts. It means the data is not having any missing values. So that's the observations that we are having. And a detailed observation, if you are really looking into, here is what we have got, that there are 10,000 rows and 18 columns. After that, there are no missing data in all of the columns, as the non-null values are 10,000. The decimal values are stored as float 64 type, as you can see over here. And then the integer values are stored as integer 64 type. Along with that, if there is a non-numeric data, then we are going to store this as an object type. If it is a string, then it's still going to be an object type. After that, the total memory usage to store this particular data frame, we are having 1.4 plus MB used over here. So yes guys, that was about exploring the dataset with the help of pandas. Now in the upcoming video, you will see that we are going to create visualizations and again get some kind of insights from the dataset that's really going to help us to do some kind of training and later on make some kind of observations on top of that. So stay tuned for that.